Namaste students, welcome to our educational channel PAATHSHALA Pandit. I am Ayus Bhattacharya. In this channel, you will get all the videos related to the academics of maths and science. If you feel this video is really helpful, please like it, share it with your friends, and also please do not forget to subscribe to our channel. If you have any type of doubt in your mind, please feel free to post it in the comment section. I will surely reply to it. Thank you very much. Hello students.
Hello, sir.
Do you know the types of triangles based on the lengths of the sides?
Yes, sir. Scalene triangle, isosceles triangle, and equilateral triangle.
Okay. Can you define them?
Yes, sir. Scalene triangle has all the lengths unequal, and isosceles triangle has two of its sides equal, and equilateral triangle has everything equal.
Correct. Very good. So today we will learn about the theorem of isosceles triangle. It is also called isosceles triangle theorem. Alright. So let's write it. Isosceles triangle theorem. First, let's see the theorem. Okay. So the theorem says if two sides of a triangle are congruent, then the angles opposite to them are congruent. This is the theorem. So now you tell me, what do we have to do next?
I don't know, sir.
First, we need to draw a triangle where two of its sides are congruent, because that is what it is written in the theorem, if two sides of a triangle are congruent.
Oh, okay. Sorry, sir. Sorry.
It is okay. So now let's draw the triangle like this. This side and this side is congruent. So let me mark it like this. If two sides are congruent, then we show it like this. Okay. Now let's name it ABC. A, B, C. Alright. Now let's write the given part and the to prove part. Okay. Given part is in triangle ABC, side AB is congruent to side BC. This is the congruent side. Alright. Now the to prove part. The to prove part is, we have to prove angle ABC, means this angle is congruent to this angle ACB. This we have to prove. Okay.
Done, sir.
Alright. Now we have to do a construction here. So write construction part. Construction. The construction part is, see, we have to draw a bisector of angle BAC like this. Okay. And it will meet here at D. So if we construct it, it will look somewhat like this. Alright. This is D. Alright. If you want, means during construction it will come out of here, which is fine. If it comes out like this, it is fine. No problem here. Just name this point as D. Okay. So what we write in the construction? We will write that bisect means to half it, to make it half. Bisect angle BAC and the bisector meets side BC. You can write side BC as like this also. This is actually line segment BC, which is fine. BC at point D.
Done, sir.
Alright, now comes the proof. Now see, we have to take two triangles, this one and this one. So in triangle ADB and triangle ADC, which things are common? AB is equal to or is congruent to AC because it is given first of all. So we will write AB congruent to, this is congruent sign, AC. Remember, in proofs where we have to write this is congruent, isosceles triangle theorem, and in this chapter itself replace equal to by congruent sign. Okay, it is the best way of representing it. Alright, AB is congruent to AC and it is given. In bracket you have to write it given. Now what is left? See this thing AD. Okay, one thing we left to draw here. If you bisect an angle, make sure you do something like this. Like when we showed it that this line and this line is congruent, what we did, we put similar marks on both sides. Same here, we have to put similar marks here and here. Okay, so now angle BAD is congruent to angle BAD CAD. See, try to do it in a similar manner or in a mirror fashion, like I am saying how. BAD, what is its mirror image? Means just the reflection. BC, so CAD, like this. One is like this and the other is like this. If you do it like this, BAD and then DAC, it will look a bit odd. Okay, so do it like this only. BAD CAD. Okay, and this is construction. This is construction because we bisected the angle. And another thing is this only. AD is equal to AD is not equal to, actually it is congruent. AD is congruent to AD. Why? The reason is common side. Okay, so now by seeing it only, you can imagine what two triangles are congruent. Means these two triangles are congruent, we can see it. But now how to write it? Therefore triangle ABD, suppose we started from here, ABD, then what are the corresponding sides? Means what are the similar points in congruency? A is congruent to A, which is same. Now B, when B is being written, we will have to write C because exact reflection we can see it. B will become C and D is D only, means it is a common point, A, C, D. Alright, which test is this? This test is SAS test. Okay, this is SAS test. Now what can we write? We have to write this thing only to prove. So therefore angle ABD, write this ABD. Alright, ABD you write first, then write ACD. Now what is the reason behind it? You know the reason that these are congruent triangles, so of course these will be congruent only, but you have to mention a reason. The reason is corresponding angles of congruent triangles. All right, this is the reason behind it. All right, so what you have to do is, either you can write this whole thing. If you write this whole thing, it will be better. If it is not possible, suppose in exam time is running out of hand, you can write this only, CACT, only this much. Okay, this is the short form. Now see, what you have to write is angle ABD is ACD. Now you can write angle ABC. Therefore, angle ABC is congruent to angle ACB. This whole thing, ACB. See how to mention this reason now. B, next to it is D, next to it is C, all in a single line. Okay, so you can write it like this, BDC. You can write it like this. All right, so we got this. All right, now what is the golden statement we have to write? Yes, hence proved. Okay, proved. Now let us see what is the converse of isosceles triangle theorem. Do you know what is the meaning of converse?
Sir, similar to opposite.
Yes. So now let's see the converse. Let me write the topic. Converse of isosceles triangle theorem. So the theorem is, the theorem says, if two angles of a triangle are congruent, then the sides opposite to them are congruent. In the first one, where given, means here it was written two sides of a triangle was congruent or are congruent. Here it is written two angles of a triangle are congruent, and we have to prove that the sides are congruent. Now we have to prove it. Earlier it was angle proving, now it is side proving. Okay, so this is why it is known as converse, means somewhat like opposite. All right, so now tell me, what else do we have to write?
Sir, diagram given to prove construction.
Correct. So let's draw the diagram. A, B, C. Now angle ABC is congruent to angle ACB. Okay, this it is given that if two angles of a triangle are congruent, means it is congruent from starting only. Okay, now what should be the given here?
Sir, angle ABD is congruent to angle ACD.
Correct. Given is in triangle ABC, angle ABC is equals to or congruent to angle ACB. Now tell me, what is we have to prove?
Sir, side AB is congruent to side AC.
Very good. To prove AB AC. Now we have to again bisect this triangle like this. This angle we have to bisect. This we have to make some marks here to denote that these two angles are equal. All right, now let's name it D. Write in the construction that, first write construction. Write here that angle ABC, or wait, angle BAC is bisected and the bisector meets side BC at D, or wait, not D, write point D, okay, point D.
Sir, instead of actually doing the construction, can we just draw it freehand?
Yes, you can, but remember you have to make these arcs also. If you are drawing it freehand, like just like this, then take care that it looks real, means not just anyhow you do, then it will reduce your marks, you will not get full marks. So take care that it looks real, otherwise yes, you can do that. Okay, now comes the proof part. Proof. See, what is the proof? Just like it was before. In triangle ABD and triangle ACD, you can continue to write the proof along with me because you now know the pattern. Okay, first take what is given already. ABD, angle ABD is congruent to angle ACD, which is given. Then comes the construction part. BAD, angle BAD is equals to or is congruent to angle CAD, which is construction. Then comes the common side. Side AD is congruent to side AD, which is common side. Now due to these 3 points, what we will see from them is the triangle ABD. By looking at the diagram itself, we know that these two triangles are congruent, but we have to prove it. So triangle ABD is congruent to triangle ACD. You go like this, ABD, then you have to go like that, ACD, which is by side, no, here it is ASA test. 2 angles, one side given, ASA test. So now what can we take out from that? AB. Therefore AB, here also therefore AB is congruent to AC by, in the previous few minutes we saw that corresponding angles of congruent triangles. Okay, here we will see corresponding sides of congruent triangles, So here it will become CSCT. I am writing it in short only, CSCT. And now the golden statement, hence proved. Okay.
Okay, sir. Okay.
Now go home and revise properly. All right.
Sure, sir. Thank you, sir.